Hi, welcome to Artificial Neural Network. Here we are having some important parameters in artificial neural network. First one is learning rate, which is deciding a step size in convergence, which is a hyperparameter and its range from 0 to 1. Mostly we will use 0.01 or 0.001 or 0.0001, or we may use 0.05 or 0.005 or 0.0005. So this learning rates used to update the weights during backward propagation. The learning rate controls how quickly our neural network model is adapted or learning the patterns for given input, and smaller learning rates require more number of training epochs, which is giving smaller changes made to the weights at each iteration. Where if you use the larger learning rates, for example, learning rate is 1 or 2, like alpha equal to 1, alpha equal to 2, then it will not converge quickly, but there is the possibility of rapid changes. And bias is another one parameter used in the neural network, which is a given as a input to the neuron. It will be always on. That means the bias value b always it will be input to the bias will be 1, input to the bias will be 1. So here mostly we will use a bias like this. So here this value will be 1. Parameter will be different, bias parameter will be different, but bias value will be 1. So bias is like a intercept in the y-intercept in the linear equation. It is an additional parameter in the neural network that is used to adjust the output along with the weighted sum of inputs in the neuron. So here mostly what we will have, g equal to w1 x1 plus b. So here the bias is used to adjust the value of the output along with weighted sum. Then it is called bias is called constant because of its value is 1, which used to help the model uh, to become best fit for given input data set. Weight is deciding how fast the activation function will trigger, and bias is used to delay the triggering of activation function. Here the weight w is used to trigger the activation function at a fast rate, but the bias is used to delay the triggering of activation function. So these are two parameters are important for neural network. And there is some problems in neural network: overfitting. So here the model is possible to overfit with the given training data samples. So there is the possibility of much variance in the testing error. So for that, what we have to do, we should use some penalty parameter to avoid the overfitting. So this is one of the issue here. The best method to make avoid the overfitting, we have to use the balanced data set with sufficient number of samples. This will reduce the overfitting by using regularization method. And the network size is also impact the solution. Here when you are having the too many layers and many hidden units in the hidden layer, which is very expensive. So we have to reduce the complexity of the model by reducing the number of layers in the network, and also number of neurons in the each layer. There is no best practice to define the number of layers. We have to make trial and error, and start with small amount of hidden layers, and you can increase one by one until you are getting best performance. And one more parameter is weight regularization, which is avoiding the overfitting by adding constraints to the weights. There is two regularization method: L1 regularization, lasso regularization, and L2 regularization, ridge regularization. So here we will add that penalty parameter. This is lambda is penalty parameter, and this is the L2 regularization added with the cost function to reduce the weightage of parameters. So it will reduce the magnitude of the parameters. Then another one problem is available in the neural network: early stopping. It is used to stop the iteration process if it reaches the convergence convergence earlier than given iterations. So for example, I am giving the maximum number of iteration equal to 100. Maximum iterations is 100. So if I got three consecutive error value close to the 0 like this, say iteration number 25, I got 0.03, iteration number 26, 0.03, iteration number 27, I got 0.031. So I can stop with this 27 number of iterations before reaching the 100 iterations. I have given 100 iterations, but I got convergence at the 27th iteration, so I can stop with the 27 iteration. No need to go for 100 iterations. That is called earlier stopping. And the next one is a dropout. So dropout is one of the regularization technique which is used to prevent the overfitting. So here what it will be happen, you look at that, so many connections are there. So many connections are having so many weights. Each connection is having weights. So in this we may randomly set some of the weights may be 0. So here look at that, some of the weights are made as a 0, so very few connections are there. So in this so many connections, only few connections are allowed. So remaining rest of the connections are made as a 0. For example, I am having four connections: 0.1, 1.7, 0.7, minus 0.9 are the parameter values. Here when when I'm applying the dropout, so I can made randomly some of the values made as a 0. You look at that, these two values are made as a 0. So that connections are now dead. That connections are now red, which is randomly distributed. The dropout parameter is used to control the network by setting the 0 to number of weights. So here the rate between the 0.2 0.5 is the common. So these are all some of the parameters and approaches used to optimize the neural network. Thanks for watching.